The double-slit experiment cannot prove light is wave. Enclosed. Explanation form Google Chrome AI Overview. Illustrations of particle and slit. The double-slit experiment argument. Attempts to observe which slit a particle goes through by placing. Detectors near the slits cause the interference pattern to disappear. That is, 1. When the particle is observed, no split. 2. When the particle is not observed, split. My argument, with or without extra device, the particle is always being observed, influenced, that is why the wave pattern. Although particle is still particle and not wave. Also, split or not, shall not create wave pattern. Here is the reason. The experiment focused too much on the single particle, a quantum, and ignore other particles, quantum s. If it is quantum, it is not fixed, if is different every single instance. What other particles? A. The light or electron passing through the slit, in your words A. Quantum. B. The particles making up the slit, also in your words quantum s. You're conscious, the slit is static. It is not, it is dynamic. When a quantum passing in high speed through quantum s dilated, creating wave pattern. It is not because the particle changing from particle to wave creating wave pattern. Skip the following if you are familiar with double-slit experiment. Reference, Google Chrome AI Overview. The double-slit experiment demonstrates the wave-particle duality of light and matter. When particles, like photons or electrons, are fired at a barrier with two slits, they produce an interference pattern on a screen behind the barrier, similar to what happens with waves. This pattern indicates that even individual particles can behave as if they pass through both slits simultaneously and interfere with themselves. Elaboration. The experiment was first performed with light, showing that light, which had been previously thought to be a particle, also exhibits wave-like behavior. Later, variations of the experiment were done with electrons and other particles, revealing that they too exhibit wave-like properties. Here's a breakdown of the key aspects. Interference pattern. The most striking result of the experiment is the appearance of an interference pattern. This pattern consists of alternating bright and dark bands on the screen behind the barrier. This pattern is characteristic of wave interference, where waves can constructively and destructively interfere with each other. Wave-particle duality. The experiment highlights the concept of wave-particle duality, which suggests that light and matter can exhibit properties of both waves and particles depending on the nature of the experiment. Single particles. Even when the experiment is performed with individual particles, like electrons, the interference pattern persists, meaning that a single particle can behave as if it has passed through both slits simultaneously and interfered with itself. Observation and collapse. Attempts to observe which slit a particle goes through by placing detectors near the slits cause the interference pattern to disappear. This observation further emphasizes the role of observation in quantum mechanics, where the act of measuring a system can affect its state. Young's double-slit experiment physics. In essence, the double-slit experiment reveals the strange and counterintuitive world of quantum mechanics, where particles can behave as waves and where the act of observation can influence their behavior.